Section 11.5, area of circles and sectors. We are going to talk about areas of circles and then an area of a sector, which is just a part of a circle, kind of like a slice of pizza. So here is your formula for area of circle, pi r squared. I know that you already know that, but what's interesting, or might be interesting for you, is to go ahead and copy and paste that link, and it kind of shows you sort of a visual of why the area of a circle is pi r squared, and it might be interesting for you to watch. So remember, the area of the circle is pi r squared, and just like with circumference, we can give both the exact and an approximate answer. So if you look at this first problem with the radius given of 14, we know the area is pi r squared. So we simply fill in our radius squared. So our exact answer is 196 pi inches squared. That's your exact answer. You have not rounded anything. You have not lost any of those decimal places. Okay? If you want the approximate answer, then you go ahead and take 196 and multiply it by pi, which gives you approximately 615.75 inches squared. So, not too difficult, but just remember to understand the difference between approximate and exact. So you go ahead and try the second example, and then you can check back to the notes to make sure you're doing it correctly. Don't forget your units. Okay, so now we're going to do some word problems. And we are going to be given the area, and we're going to have to work backwards to find the radius. So the area of the circle is 58 square inches. So again, I start with my formula. Area is pi r squared. So I'm going to put the 58 in for the area. And then what I'm going to have to do to solve this is simply divide by pi. And what that gives me basically is, well, you could actually leave it like that, but if I go ahead and take 58 and divide it by pi, that gives me approximately 18.46, and that is equal to your radius squared. Now you need to take the square root of each side, and that gives you a radius of approximately 4.3 inches. Okay, so you go ahead and try this next example, and then you can check back to your notes, but I do want to remind you that you are going to have to find the diameter. So all I would need to do for the problem that I just did, if I wanted to find the diameter, is multiply it by 2. So again, not too difficult. So let's move on to talking about areas of sectors. So first of all, a sector of a circle is the region bounded by two radii of the circle and their intercepted arc. So in the diagram that you see here, this is the sector. So that is the sector right there in orange. So we would call that sector APB. Well, it turns out, just like the arc length compared to the whole circle, circumference, is the same ratio as the degree compared to the whole circle 360, the same is true for the area of the sector. So if we know that degree measure, we know the arc measure in degrees. And so the area of the sector compared to the area of the circle is the same ratio as the arc measure compared to the 360 degrees where you go around the whole entire circle. So it's really the same thing as arc length. So if you understood what you were doing with that, this should be fairly straightforward. Now you can see that the textbook actually goes through and gives you this solved for area of sector APB. And then you have a slightly modified formula. But really all they did here is multiply by pi r squared on each side. And that's where you get this formula right here. So that's where that comes from. But again, personally, what I like to do is I like to just use this simplified formula, because the area of the sector compared to the area of the whole circle will be in the same ratio as the degree measure compared to 360. And honestly, it's also equal to the arc length compared to the circumference. So actually, we could actually set these two ratios equal to each other as well. But of course, we wouldn't set up all three at the same time. So let's see if we can practice some problems here. So it says find the area of sector ACB. So we can see that the degree measure is 97 degrees. So the area of the sector, let's call that x, compared to the area of the circle, which is pi times our radius squared, so 8 squared, is going to be the same ratio as the degree measure, 97. That's the degree measure of the central angle right here, so that is also the degree measure of the arc. So now all we have to do is cross multiply, and when we do that, we get 360x is equal to 97 times 64 pi. And now we're just going to divide by 360. And then that gives us that our area of our sector is approximately 54.18 units squared. Okay, so now let's do one here where we have to work backward. Well, actually, this says find the area of the sectors. That was coming up next. Find the area of the sectors formed by angle ACB. So we could find the area of this sector first. So the area, we'll call that one x. So the area of sector ACB compared to the area of the circle, which is pi times 10 squared, is going to be in the same ratio as 60 compared to 360. So we can cross multiply here and solve, or what we might want to do is just reduce this ratio and maybe put an x in there. This would be 100 pi. And really, actually, we could cross multiply for sure, but really all we need to do is to solve, since this is divide by 100 pi, we could multiply each side by 100 pi. That saves us a little work. So then what we get is x is equal to approximately, well, the exact answer would be 50 pi over 3, which is approximately 52.36 inches squared. Now, that's sector ACB, but it said find the areas of the sectors. So they also want us to find this sector as well. And that's really called the same sector at this point. But all we would really need to do, we could set up the ratio again, but all we really need to do is take the area of the circle and subtract the area of the sector we found. So we take 100 pi and we subtract 52.36. So 100 pi minus 52.36 gives us approximately 261.799. So that would actually round to 8, and they did give us units, inches squared. Okay. So now here is where we're going to practice working backwards. If they give us the area of the circle, or they give us the area of this sector right here, they want us to find the area of the circle. So again, we're going to set up the area of the sector, 17.46, compared to the area of the circle. We'll just call that x. That's what we're trying to find. That's going to be in the same ratio as the degree measure, 100, compared to 360. And so really now, again, we can cross multiply here to solve, and we would get 100x equals 6,285.6. And then we're going to divide each side by 100, which Really, we're just moving the decimal point over. So our x value is approximately 62.86 meters squared. Okay, so now you can try this second example. See if you can do the same thing. This is the area of the circle. They want you to find the radius. So once you know the area, to find the radius on that second problem as a hint, remember, then you would set that equal to the area equals pi r squared and solve for r. But I'll let you try that one on your own so you can practice working backwards, and then check the answer key in the notes for more information and to make sure you got it correct. So here's a problem that's a little bit more involved. Okay, so let's work through each piece, and you don't always have to do these in order, but it says the area of circle Z is 124.4 square centimeters. So that's the area of the whole circle. The area of the sector XYZ, so this sector right here, is equal to 28 centimeters square, or yeah, centimeters squared. So that's the area of this sector right there. So we want to find the radius. Well, this is the same thing we would have done on that you would have done on that last problem. Once you know the area of the circle is 124, so area is pi r squared. So we know that 124.44 is equal to pi times our radius squared. So now we're going to divide each side by pi. And then that gives us that our r squared is equal to 39.61 approximately. And now I'm going to take the square root of each side, and then that gives me a radius of approximately 6.29. So my radius is 6.29 centimeters. So now I want to find the measure of the arc length. So I am going to try to find this degree measure right here. I'm going to find like this degree measure. So remember, the area of the sector compared to the area of the circle, so I'm going to do that work right down here. So the area of the sector 28 compared to the area of the circle 124.44 is the same ratio as the degree measure, so the measure of arc XY compared to 360. And so all I really need to do to solve this problem, since I'm trying to find this and we're dividing by 360, we're going to multiply each side by 360. And when we calculate that all up, that gives us 81 degrees for the measure of XY. So we'll take this out and we'll put in 81 degrees and 81 degrees. So those are the same. Now we want to find the perimeter of the shaded region. So the perimeter is the distance around. So we have this piece right here, which is the arc length, but then we also have to add in the radius. That would be the perimeter. So we know we're going to take 6.29 and we're going to add it with 6.29. And now we need to find the arc length. So to find the length, I'm going to do that part down here. To find the length now of XY, arc XY, that arc length compared to the whole circumference, which is pi times our diameter, or I guess I'll go 2 times pi times our radius because maybe that will be more clear to you. 6.29 is mean the same ratio as the degree measure that I just found, 81 compared to 360. So again, since I'm solving for this length of the arc and I'm dividing by all that, all I'm going to need to do is multiply each side by 2 pi times 6.29. And again, make sure you're using your calculator to calculate this to make sure that you're doing it correctly. But what you get for the length of xy then is approximately 8.89 centimeters. So we're going to add 8.89, all those three together, and that is going to give us the perimeter of the shaded region is 21.47 centimeters. What is the circumference of circle Z? Well, that's pretty simple because it's just pi times the diameter. So it is really 6.29 times 2, which is 6.29 times 2, just to make sure I do it, 12.58 pi, which is approximately, so if I just multiply that by pi, that gives me 39.52 centimeters. The length of xy, I already did that. Okay, that's down here. So that is 8.89 centimeters. And the perimeter of the unshaded region, well, that would be this, and all of this. So again, I'm going to take 6.29 plus 6.29, and now I need to find that other larger part of the circumference. So really what I'm going to do for that is to take the whole circumference, which is 39.52, and I'm going to subtract the arc xy that I got, which is 8.89, and so that equals 43. No, that equals approximately, sorry about that, that is 30.63 centimeters. So now I'm going to add that 30.63, and so now I get approximately for the perimeter 43.21 centimeters. All right, we're going to do one word problem together, and that'll be it. And then I'll have you try the second one on your own, and you can check back to the notes for it. So we want to find the area of this shaded region. So we want to find these pieces right here. So how do we do that? Well, we're going to find the area of the circle, and we're going to subtract the area of the triangle. Well, the circle part is easy. That's pi times 8 squared, or 64 pi. But what are we going to subtract? Well, let's work on the area of the circle. The area of this triangle. Notice that is an equilateral triangle. So all of these are 60 degrees, okay? We know the area is equal to 1/2 the base times the height. So 1/2 the base is 8, because this is 8. But what we need for the height is we need to be able to find this piece right here for the height. So that whole thing, the 8 plus that little piece down there of the height. Well, how are we going to do that? Well, we can break this up here into another triangle. And what we have here is this splits it into this little piece of the height right there. What that does is splits that into a right angle right there. And this is that little h I'm trying to find right here that I'm going to add to the 8. And what that gives us is splits this in half, okay? Because remember, in an isosceles triangle, the height is the perpendicular bisector, the median and the altitude. And what this also does over here, and it splits that 60 degree angle into 30. So we have our 30, 60, 90 degree triangle where The longer side is X, and my triangle is not drawn very well here, but the longer side is going to be 4 root 3, because this is 4, this is 8, and this is 4 root 3. So now my height is going to be 8 plus 4 root 3. So now I'm going to multiply 8 plus 4 root 3. That's my height that I just found. So now when I calculate that together, that gives me about 59.71. So now when I take and subtract that from the area of the circle, I get approximately 141.35 centimeters squared. All right. So I'm going to stop here, but here's an extra word problem.